Welcome to mathematics lesson. We are covering a form 2 topic referred to as indices. So we are going to cover the 9 laws of indices. So I am your teacher, Joseph Rudel Opati. Welcome to our lesson 1. Remember, indices is a topic which forms the foundation of another form 2 topic referred to as logarithm. It also forms the foundation of another form 3 topic referred to as further logarithm. So further logarithm will be covered in form 3. Now, this is how we're going to cover the topic. We shall have the introduction part where we define indices. We're going to learn the meaning of the term indices. Then part 2, we are going to discuss various laws of indices. Part 3, we shall discuss the application of the laws of indices. And part 4, we shall focus on index or exponential equation. But in this first, of course, lesson, we shall focus on introduction and covering of only the first law of indices. So this is the introduction. The introduction, we want to discuss and of course focus on the meaning of the word indices or the term indices. Now, numbers can assume different forms, of course, as shown below. We have a half is equal to 0.5 is equal to 5.0 times 10 power negative 1. These numbers have the same value, but they have different outlook. They look differently, meaning they have assumed different forms. A half is in fraction form, 0.5 decimal form, 5.0 times 10 power negative 1 is in standard form. Now, let's look at another example. 5 power 3 equals 5 times 5 times 5 is equal to 125. Again, the value of this and that is the same, but now they have assumed different forms. 5 power 3 is said to have been written in index form. So this one is what? This number is assumed index form. 5 times 5 times 5 is said to be written in factor form. Of course, 125 is said to have been written in expanded form. The word expanded comes from the word, of course, expansion, which means what? Joining smaller units to get a bigger unit. So here we have what? 5, 5 and 5 being smaller units which are combined to give us the bigger unit 125. Now, in case I'm given 125 and I need to get the 5, 5 and the 5 back, what do? We factorize. This is what we do. So we have 125. We argue that 5 goes there 25 times. 5 goes into 25 5 times. 5 goes into 5 1 time. So we are saying in the end 125 can be broken down into 5 times 5 times 5. So what do you call this? Factor form. Because we have obtained this using what process? Factorization process. So 5 by 5 by 5 is in factor form. 125 is in expanded form. For today, our focus will be on the number in index form, which is 5 power 3. Now, a number in index form has two components as shown below. We have the number here occupying the lower position, that number occupying the higher position. The number in this lower position is called a base. The number in the upper position is called an index. Now we want to focus on what we mean by an index and a base. So what is an index and what is a base? Now, the base is defined as the number that gets multiplied by itself. Now let's consider 5 power 3. 5 power 3 means you multiply 5 by itself 3 times. Now focusing on 3 and 5, 5 is the number which of course now is the base, because it's the number which is being multiplied by itself. So what's a base? A base is a number which is multiplied by itself. Good. Now we go to definition of an index. What's an index? An index is defined as a number that says how many times to multiply the base by itself. So here the base 5 was the number being multiplied by itself, but 3 is the index. 3 will tell us how many times to multiply the base 5 by itself. So we multiply 5 by itself how many times? 1, 2, 3, because the index is 3. If at all we had 5 power 2, that could mean I multiply 5 by itself 2 times. Now 5 power 4 would imply I multiply 5 by itself how many times? 1, 2, 3, 4. So in summary, what have we said? The base is the number being multiplied by itself. What about the index? The index is a number which will tell you how many times to multiply the base by itself. So an index is also referred to as a power or an exponent. Now, of course, as you have seen, an index is usually written as a small number to the right and above the base number. So the base number is 5. Where is the index written? To the right and above, of course, the base number. So of course, when we're talking about one, talk about index. Many, we talk about what? Indices. So we are done with our introduction. Now I hope you have understood what we mean by an index. Now we go to our next part, which will be the beginning of the coverage of laws of indices. I've insisted that how many laws? There are 9 laws, but for this lesson I'm only going to cover one law. Now which law is that? It is a law of multiplication of numbers having similar bases, and this is how we state the law. X power n times x power m is equal to x power n times, plus m. I repeat, x power n times x power m equals to x raised to the power of n plus m. For you to understand these laws in a better way, always remember for any law we have what? A condition attached to the law. So in this law, what is the condition? Let me just give that out. The law is given by x power n times x power m is equal to x power n plus m. So the conditions in this law will be, you must have what? The same base. And number 2, you must be multiplying. So whenever we multiply and the base are the same, what do? We add the powers or the indices. Now let me give a simple illustration before we proceed, of course, now to discuss our first example. Now we have 2 to the power of 2 times 2 to the power of 3. Now 2 power 2 means you are multiplying the 2 by itself 2 times. The 2 power 3 means you are multiplying the 2 by itself how many times? 3 times. Then remember, we have what? This multiplication as the initial operation, which I have it here. Then in the end, it means what? We are multiplying the 2 by itself how many times? 1, 2, 3, 4, 5. That means we shall end up with what? 2 power 5. We are saying this outcome can be simply achieved by applying the law of indices in a case where we have what? Similar bases when we multiply, where we are going to add what? 2 plus 3 to give us what? 2 to the power of 5. So whenever you multiply, what do you do to the powers? We add the powers. So having covered that illustration, we can quickly go to our example 1. Now, example 1, what does the question say? Example 1, simplify the following, leaving your answer in index form. Our first, of course, question is b power t times b power r. So let's have the solutions here. So solutions. Now, part A, b power t times b power r. What do you get? Since we are multiplying and the base are the same, we are going to say the outcome will be b raised to what? T, of course, plus r. We go to number 2. Of course, now that's the end of that workout. We have 5 power 3 times 5 power 7. What will you get? 5 raised to power 3 plus 7, which will give us what? 5 power 10. Then part C, 7 power 5 times 7 power negative 2. That will give us 7 power 5 plus negative 2. Now, remembering your integers concept in form 1, that will translate to what? 7 power 5 minus 2. In the end, what do we have? 7 raised to power 3 as the eventual, of course, now answer. We are done with the first law. Now, this is your homework. So attempt this question just to confirm you have understood that first law. Then we shall check on the results, of course, now in our next lesson, lesson 2, before, of course, we discuss law number 2. So what is the question for your assignment? Simplify the following, leaving your answer in index form. That is Roman 1, t power 3 times t power 4. So what do you get? H power 2 times h power n. What do you get in that case? 10 power 7 times 10 power negative 2. What shall we get? 13 power 6 times 13 power 4. What shall we get? So this marks the end of what? Our first lesson. So check on the next lesson to confirm if you got the answers right, and then to discuss law number 2. So have a good day.